Okay, we're gonna do a quick video explanation of some of your independent practice problems. Just want to kind of recap that you need to be using the previous properties that were talked about in the other two previous videos. So you're gonna have some problems to do with each shape: a rectangle, a rhombus, and a square. Now, for your rectangle, this part here, this is just your notes, okay? And I want you to use some other information to apply onto the problem. So it states here that all the properties of a parallelogram, those were 5 properties that you can use here on this shape. In addition to, all angle measures are 90 and the diagonals are congruent. Now, another property that exists, and I'm going to try to use highlighter color coding, is that the diagonals create isosceles triangles. Now, they don't bisect, but if this little piece of this angle here, I don't know if you can see that, and this piece here are the same. So the top and the bottom are congruent, and they're congruent isosceles. Now, with that being said, that also lets us know, and I think this should work, this little angle here, and this angle here, and this angle here, and this angle here are also going to be the same. So if I know one, then I know there are others as well. Now, your first question here is asking you to take this given information, the fact that it's a rectangle, so it has all these properties here and this relationship here, put the angles, and we're going to label the given. So it says LM is 16, so we can put the 16 here, and then MN is 12, we can put the 12 there, and then they give us angle 1, which is 53, so we can put the 53 in there. And now they want you to fill in the given information. So they want you to find missing angles and missing sides. The thing that you have to remember, and I'll go to right here to number C, to letter C, to find a missing side, and they're referring to this side LN, you're gonna have to use the right triangle that exists in there. So if you need to, let me fix that. If you need to, I got that. Oh, you can draw this right triangle. This is 16 and 12. You're trying to find opposite the right angle, which is the hypotenuse. So you're going to have to remember to use Pythagorean theorem. A squared plus b squared, equals your c squared. So those are your hints. The color coding that I did above and Pythagorean theorem are your hints to find missing sides or parts of the sides. Now, once I have one of the diagonals, the whole diagonal, then I remember all the properties of a parallelogram says the diagonals bisect each other. So each of these little pieces are going to be the same too. So that helps you with the problem solving there. Now, when you get to your rhombus, again, it has all the properties. It has all the properties of the parallelogram. So that's those 5 properties. Plus, all the sides are congruent, all the diagonals are perpendicular, all the diagonals bisect the opposite angles. So with that being said, this angle here and this angle, those little pieces are going to be the same. So I can color them the same if I wanted to. Same thing here. Now, I stated the first thing I kind of talked about in my video is that the diagonals in a rhombus create 4 congruent right triangles. That's very important in helping you find your missing parts, because since there are 4 congruent right triangles, again, right triangles, then I can use my Pythagorean theorem again. Or, depending on the angle measurements, your special right triangle rules. And that, I believe, applies for this one. So if you look here, I'm going to label the given information. We have a rhombus, so we know all these sides are going to be congruent. We know WX is 4, so I'm going to put a 4 there. Make sure you can see that. Let's put that in blue. There's 4. WX xy, so that's this whole angle here is 60, but remember the diagonals bisect opposite angles, so that means each one is going to be 30 and 30. And with the diagonals being perpendicular, that's a right angle right there. I'm hoping now that you see that if this is 30 and I was just focusing on, I was just going to focus on just one triangle here, like there, and I have one of the angles, then the other angle is also acute and it would have to be 60. So each one of these triangles is a 30-60 triangle. So your hint for these problems is to remember your 30, 60, 90 rules, which is when, remember, if I was to draw one, you would have a long leg, sorry, that's the short leg. You would have a short leg, that's opposite the 30. You would have a long leg, and you have the hypotenuse. And you got to remember your short leg, this is your home base, so you always start here. And if I'm going short leg to the hypotenuse, that's always times 2. And if I'm going short leg to the long leg, if I multiply it by the root 3, that would give me my long leg. So those are some rules you had to remember for your rhombus for this problem, because I believe they're asking us to find, like if I look right here on this section right here, find WO. Well, if I look, WO is the short leg, which means it's going to be half the hypotenuse. And right there, there we go, opposite the right angle. There's your hypotenuse in that one triangle. And that's your hint to hopefully fill the rest of them. And then the last one is your square. This is the most perfect of all quadrilaterals. And that is that it has all the properties of a parallelogram, a rectangle, and the rhombus. It has all of the properties. Now, a special relationship that happens in a square is that these diagonals, if you were to draw them, are congruent, and this is kind of off, so let me see if I can fix this one, are congruent, and perpendicular, and they bisect. So that means it's always going to turn these triangles into 45, 45, 90 triangle. Every single one of them is going to be a right isosceles. And so you use that to help you with this problem, because they tell us that EF is 10, and so that means all the sides are 10. And then I know all the angles are going to be 45 and 45. And if I was looking at just one of these right triangles here, this would be an example of using our special right, our right isosceles. I'm going to do isosceles is when we have a leg, and whatever the leg is times 2. Your hypotenuse is the leg times radical 2, because your two legs are the same. So right now they're telling me I see those two legs 10 and 10, and that'll help you get to your hypotenuse EF. So there's some hints that I'm going to let you have to problem solve and use this to get your independent practice done with your notes, and then you need to attach them to the assignment on Teams. And if you have difficulty attaching the picture of your notes in your independent practice, just email it to me. All right, thanks. I hope this gets you through. No. What did I do here?